Red-footed boobies are the dominant large seabird on this island. And we're really interested in, again, how they're transferring nutrients, where their food is coming from, and that land-sea connection. Scott Schaefer, who's advising on this project, went out with me, and we caught a few boobies that we'd tagged the previous night, and we hooked them with that noose over their neck and pulled them off their nest. And then one of us grabs them, and we just remove that tag, and we also take some samples. We can take diet food samples, and we can take blood samples and some measurements. And then we went out and put some new receivers on these birds. And the receivers are GPS receivers, and they tell us within 10 meters where the bird's been that day, taking measurements every 10 seconds. I really like working with the boobies. They've got a lot of personality. They look at you at the nest, and you can tell what they're thinking a little bit. Whereas the terns kind of are so loud and raucous, so you just get overwhelmed. Partly that we just want to know how many there are on Palmyra and getting some baseline data to know if they're declining or not. The people think rats are a real problem around here, and they're debating eradicating them and all, and we want to know how many of them are fudging, and if they are in fact being badly hit by rats.
We've been working here for about 4 years on the coral communities. In fact, Stanford SEA has come here to study the coral reefs of Palmyra every other year. This is our third trip now. So we're tracking how the corals are responding to changes in the ocean, and also changes caused by long-term temperature changes of half a degree or so, things associated with global warming and man's activities on the planet.
It's amazing that we get the chance to come out here and do this, and as an undergraduate to get the opportunity to go on a research vessel and tell it where we want to station and what we want to happen, and get that data. It's quite outstanding.
Some of the students at Stanford SEA a number of years ago, the last two cruises, actually compiled their direct observations and published a paper that showed unusual high abundances of top predators like sharks, groupers, snappers, and in turn the rest of the system looks different. The reef looks healthier. There's lots of vibrantly healthy corals, lots of fish, lots of regrowth just in the last 2 years. In a lot of places, you don't really know whether the changes have been caused by man's activities or maybe it's an initial indication of changes caused by increase in ocean temperatures. So one of the things that we can do here at Palmyra is we know that for much of the outside community of the coral reef that there hasn't been extensive fishing here, there hasn't been extensive pollution offshore. It's a remote equatorial atoll. So this is one of the few places where we expect a singularly climatic influence on the nature of the community.
The relative isolation means relatively few visitors here in Palmyra, and so that's really why Palmyra exists as it does today, as a unique, intact system that is representative of how marine systems worldwide have been in the past. If you look across the reef, you just see things bobbing up and down, and it's just life. It's life everywhere you look.